In this video, I want to show you how to take a word formula and write a balanced chemical reaction from that word formula. So, as you can tell, I was given the names of both my reactants and my products for these two reactions. So, for the first one, I know potassium is K, and I know chloride is Cl. Now, potassium has a +1 charge, and chloride has a -1 charge. So we need to cross their charges to get the correct formula of KCl. Plus, now silver is Ag, and nitrate is NO3. Their charges are +1 and -1. Silver you might not have known right away. You would have had to look it up on your ion sheet. So I cross my charges, and the formula is AgNO3. Yields. Now I was given silver chloride, so silver's still Ag, and chloride is still Cl, and their charges are still +1 and -1. So I cross, and I get a formula of AgCl. And potassium nitrate, K is still K, nitrate is still NO3, and their charges are +1 and -1. And if I cross my charges there, I get the formula of KNO3. And now, before I finish, I still have to make sure my equation's balanced. So I have one potassium, one chloride, one silver, one nitrate, one nitrate. So I know that this is a balanced reaction. So that's how I take a word formula and I put it back into its chemical formula format. So now let's try the next one. So aluminum is all by itself, so that's just Al plus. Now oxygen's a little weird. Oxygen is known as a diatomic molecule. So oxygen's formula, when it's an element by itself, is O2. How do I know what elements are diatomic? So if you look at your periodic table, I like to call it NOF and down. So nitrogen, oxygen, and fluorine are all right next to each other on the table, and they're all diatomic when they're elements. So whenever something just says oxygen, or nitrogen, or fluorine, they're always going to be N2O2, F2. Now, I say the and down part because the rest of the halogens behave that way as well. Now, I caution you not to put a 2 every time you see NO and F. Only to put a 2, that 2 right there, when it's an element by itself, not in a compound, like you see over here to your right. So, when I go over to aluminum oxide, I'm not even looking at that 2 at all. I just want to write aluminum, and its charge is 3, oxide, and oxygen's charge is 2. So when I cross, I get Al2O3 for my formula. So now I have to balance the equation to take care of that difference in the oxygens and aluminums. So oxygen is 2, oxygen is 3. So I have to multiply this side by 2 to get my 6 oxygens, and this side by 3 to get my 6 oxygens. Now I have 4 aluminums, so I need a 4 there. And that's my final formula. Okay, these ones are a little harder, so pause the video, give them a try, and when you get back, I'll show you how to do them. Okay, so for the first one, I have potassium chlorate. So potassium chlorate is KClO3, and when I cross their charges, that's the formula for it. And then on this side, I have potassium chloride, which is KCl. Cross the charges, they're both 1s. Plus oxygen, which is O2. I now have to balance the equation to take care of the difference. So I need a 2 there and a 3 there, and I would need a 2 there. Now for the next one, magnesium oxide is MgO. Cross the charges, they're both 2s, they cancel. Phosphoric acid is a little harder. So remember, ic means 8, so that would be phosphate, which is PO4. Phosphate has a 3- charge, so I would need 3 H's in the front. And magnesium phosphate would be Mg3 parenthesis PO4 2, and water is H2O. So now I just have to make sure everything's balanced. So I have 2 phosphates, so I need a 2 there. That gives me 6 hydrogens, so I would need a 3 there. which gives me 3 oxygens, so I'd need a 3 there, which gives me 3 magnesiums, and I have 3. So that's my balanced reaction.